Right, welcome back to my channel, PepperScore Today we're going to look at more volume and surface area problems. So here's question 1 that I took a picture of. So the dimensions of an open rectangular tank is 75 centimeters by 45 centimeters by 60 centimeters high as shown in the diagram there. A solid metal cylinder of volume 37,500 centimeters squared is placed inside the tank and 42,000 centimeters cube of water is poured into the tank to just submerge the cylinder. So what just submerge means is that as you can see here, I've just drawn some diagrams with different perspectives. So here is what the tank looks with the cylinder and the water looks like when look at the sides of the lengths 75 by 60 centimeters. So as you can see, the cylinder now looks like a rectangle, and as you can see, this is the water level, and the side of the cylinder, this topmost side, is in level with the water. In our example, if we look at the sides with dimensions 40 by 60 centimeters, as you can see, now the cylinder looks like a circle, and here is the water level, which is tangent to the circle there. So that's just a brief explanation of what just submerged means. And then we need to find the radius of the cylinder, the length of the cylinder correct to 3 significant figures, and the total surface area of the cylinder, yet again correct to 3 significant figures, and taking the approximation of pi to be 3.14. Now, how to find the radius of the cylinder? When you're dealing with similar problems to this, what you can do is to draw some diagrams looking at different perspectives of the cylinder inside the tank. So let me suppose the radius of the cylinder, which is this thing right here, be r, and therefore the diameter of the base of the circle will be 2r. And notice how this diameter is exactly the height of the water right here, and we can somehow relate this to the volume of both the water and the cylinder. Now notice that the volume of both the metal cylinder and the water forms a cuboid with dimensions 75 centimeters times 40 centimeters times the height of the water, which will be 2r. And we can somehow relate the diameter of the circle with the volume of both the cylinder and the water, as so. So I can rewrite the volume of the cylinder and the water by knowing that the volume of the cylinder is 37,500. So we can rewrite that 37,500 centimeters cubed, then add that by 42,000 centimeters cubed, which will be the volumes of the cylinder and the water respectively. Alright, so this will give us 79,500 centimeters cubed, and we can approach this in another way by knowing that the volumes of both the cylinder and the water forms a cuboid with side lengths 75 centimeters times 40 centimeters times the height of the water, which we have derived to be 2r. And now we have a nice equation in terms of r, and you can solve that, giving us r equal to 26.5 centimeters. So that's one part of the question done, and let me just denote this by part A. For part B, the height of the cylinder, well, that's fortunately way easier than part A. So we know that the volume of the cylinder is 3,500 centimeters squared. So the volume of the cylinder, I'll just denote that as VC, 307,500 centimeters cubed. And by using the formula for the volume of a cylinder, it is pi times r squared times h, where r is the radius of the cylinder and h is the height or the length of the cylinder. Now taking pi to be 3.14 and substituting r into the equation, and then we'll arrive with h. So again, we have a nice equation, this time in terms of h. And solving that, you will get that h is approximately 17.0 centimeters, correct to 3 significant figures. And finally, for part C, which is the total surface area of the cylinder, we can just use the formula for the surface area of a cylinder, which is 2 pi r times quantity r plus h. And then we can just substitute the values of r and h respectively, and I'll let you guys do all of that arithmetic. Alright, so that's question 1 done. Let's jump into question 2. Alright, for question 2, it says that a thin piece of rectangular metal measures x centimeters by 14 centimeters. And for part A, it is folded into an open container as shown in the diagram by cutting a small square of length 2 centimeters each from each corner of the metal. So as you can see from the diagram, those squares are being cut off, and then it is folded to a cuboid, actually an open cuboid in fact. 120 centimeters squared of water is poured into the container, leaving a quarter of the container unfilled. And then with this information, we need to find the value of x. And for part B, the metal is formed into a cylinder of height x centimeters instead. So the x value from part A does not depend on the x value on part B. So this is a, I would say, different metal piece, but with a different x value in this case. And from the diagram here, we need to find the radius of the cylindrical container. And for part 2, 120 centimeters cubed of water is poured into the container, such that the ratio of the depth of the water to x is 3 to 5. Find the value of x correct to 3 significant figures. Right, so actually I've drawn some diagrams right here to demonstrate the folding and the wrapping of the open cuboids and the open cylinders respectively. So for the open cuboids, notice that it is being cut off to result in this weird shape right here. Now notice that if you fold this side here to this side, and fold this to this, this to that, and this to that, and it would be easier to demonstrate it if you have a piece of paper, and then if you want to fold it like that, and you'll result with this figure there. And then with this figure, 120 centimeters square of water is poured into this container, leaving a quarter of the container unfilled right there. And for the second part, which is the cylinder, notice that we can wrap this rectangular piece in such way such that it forms a cylinder. Right, so that's just a brief explanation of that, and let's jump into the solution. For part A, now first we can just find the dimensions of the cuboid made from here. So notice that this whole length is 14, and these tiny lengths are 2 and 2 respectively. Therefore, the middle length right here, I'm just going to write that right there, and that will be 14 minus 2 minus 2, which will be 10 centimeters. Same thing, we can do the same thing for x, and this time we have side lengths 2 and 2 respectively, and therefore making this middle length being x minus 4 centimeters squared. And for the height of the cuboid, notice that it is exactly 2 centimeters. Since you're folding this and folding that, these sides will match up and will make the height of the cylinder, and the height of the cylinder is 2 centimeters. And perhaps I'll just write the dimensions in this second diagram. So if x minus 4, and we have 10, and then a height of 2. Now since we know that a quarter of the container is unfilled, we know that 3/4 of the container is filled with water. So that means 3/4 of the volume of the container, I'm just going to draw a cuboid there, is equal to 120 centimeters cubed. And that tells us that 3/4 times the volume of this cuboid will be 10 times x minus 4 times 2. It's equal to 120 centimeters squared. Or perhaps I'll just write the units for the left hand side. Yeah. There we go. Alright, let me just change that into a cube. And solving this equation in terms of x will gives us x being equal to 12. So it turns out that the value of x in the first part will be 12. For part B, the metal piece is formed to a cylinder as shown, and then we need to find the radius of the cylindrical container. Right, so notice that if you rub this side in such way that will form into a circle, that means this length right here will be 14, right? Since you just rub the container and the original side of this length here, which will be 14. So likewise, this circumference will be 14 as well. Now the radius, let's just suppose the radius to be r, and therefore the circumference of this circle is 2 pi r. So we have 2 pi r, and from the diagram we know the circumference is 14 centimeters. And this will give us r is equal to 7 over pi centimeters, which I'll let you guys do the approximation. You can use pi to be 22 over 7 or 2.14, or you can input that into a calculator for better approximation. Alright, for part 2, 120 centimeters square cube of water is poured into a container, blah blah blah. Okay. Now let me just draw the water inside the cylindrical container. So it's something like that. So notice that, let's just suppose this height to be h, and we know that from the question h, the ratio of h to x will be 3 to 5. And with this information, we can infer, or we can conclude that the volume of the water, this denote this as that, to the volume of the whole cylinder is exactly 3 to 5. Now how do you do this? Well, notice that the water is inside the same cylinder, and that cylinder has a radius r. So that means the volume of the water and the volume of the cylinder is maintained. So the ratio is maintained because we know that the ratio is the same. So with this, we can see that the volume of the water is exactly 3/5 of the volume of the cylinder. And we know that the volume of the water is, given in the question, equal to 120 centimeters squared. And therefore the volume of the cylinder will be, let me guess, that will be 200 centimeters cubed. And we know we can approach this in a different way by using the formula for the volume of a cylinder. So if pi times r squared, which will be 7 over pi squared, times the height of the cylinder, which will be x, and this will be centimeters cubed. And then solving this, you'll get that x will be equal to 200 pi over 49, and you can approximate this, and that will give you 12.8 centimeters, correct to 3 significant figures. Alright, so that's done for question 2. Let's jump into question 3. Question 3 is a very standard find the volume question. So here it is. The diagram below shows a wooden block. AB is parallel to CD. The length and height of the block is 20 centimeters and 8 centimeters, respectively. The length of AC and BD is the same. So yeah, so as you can see, it is a triangular prism. First, we need to find the volume of the wooden block, and for part B, if the total surface area of the block is 1044 centimeters squared, find the length of AC. Alright, so let's just solve part A first. Part A should be technically simple since it is volume. So the volume of the solid will be the area of the base times the length or the height. Now the area of the base is the area of a trapezium, which will be a half times the sum of the parallel lines, which will be 6 plus 12, times 8, which is the height of the trapezium. That will be centimeters squared, and then followed by the length, which will be 20 centimeters. And this will give us, let's see, that will be 4, and this will be 18. So it will be 72 times 20, which will be 1,440 centimeters cubed. Alright, and for part B, if the total surface area of the block is 1044 centimeters squared, find the length of AC. Now we can just derive the surface area of a prism, which will be 2 times the area of the base plus the perimeter of the base times the length or the height. And in this case, the area of the base is, like I said, we have derived, this will be equal to 72 centimeters squared plus the perimeter of the base, which will be 6 plus 12 plus x, where x is the length of AC, and then times 20 centimeters. And remember, this is all equal to 144 centimeters squared. Now notice this will be 144 centimeters squared. So we can subtract that on both sides. We can get 900 centimeters squared is equal to, this part would be 2x plus 18 all times 20 centimeters. And now you guys just solve this equation and find the value of x. Alright, so that's question 3. Let's jump into question 4, which is the last question. Alright, so here is the very last question, which is question 4. Let a and b be positive real numbers, and let's solve for part A. Triangle ABC is folded into a triangular pyramid TDEF as shown. So just label those points DEF. Here, D, E, and F are the midpoints for line segments AB, BC, and AC respectively, as shown on the first diagram right there. If the total surface area of the pyramid is 9 times square root of 3 centimeters squared, find the value of A. Well, since we know that there is no cutting involved, so it's only involved in folding the triangle, that means the surface area of the pyramid is actually equal to the area of triangle ABC. So let's just find area of triangle ABC. And perhaps let's draw a perpendicular bisector right from C to AB, and that will touch at point D. And this could be also the altitude of our triangle. And since we know the side length of the equilateral triangle is A, and it bisects AB, that means AD equals to DB, which is equal to A half. And I'll just perhaps write that on the right hand side. That would be more convenient. And we can use the Pythagorean theorem to find the length of CD. Or you can use trigonometry if you would prefer that way. However, you would end up with a result of A over 2 times square root of 3. And perhaps I'll just show the work. So that means length CD is equal to the square root of A squared, the hypotenuse, minus A minus 2 squared. That will be 3A squared over 4, which will be A over 2 times square root of 3. And therefore, the area of triangle ABC, given our altitude CD and base AB, will be a half times AB, which will be A, times A over 2 times square root of 3, which will be A squared over 4 times square root of 3. And we know the area of triangle ABC is the same as the total surface area for the pyramid, which is 9 times square root of 3 centimeters squared. And of course you can cross out the 3's there, and then you can multiply both sides by 4 to get A is equal to 6 centimeters. Alright, and for part B, a polygon is folded into an open cube as shown. So as you can see, here is a polygon with this side length, so the distance from this side to this side is B, and is folded to an open cube as shown there. 864 centimeters cube of water is needed to fill half of the cube. So half of the cube is around here. I should approximate that. There we go. And I just write this as 864 centimeters cube of water. And with this, we need to find the value of B. And since we know that these sides, this, and this, these are all congruent, that means the size of each side length will be B over 3. And notice that it is folded up into this side right here, this imaginary square here, to make these sides match with this, and then make this side match with this, and so on. So you can conclude that the side length of the cube will be B over 3. And notice that 864 centimeters cube is half of the volume of the cube, which means the volume of the cube will be 2 times 864 meters, 864 centimeters cube, I should say, which will be 1,728 centimeters cube. And we can approach this in a different way by knowing that the volume of a cube is its side angle cube, which will be b over 3 cube. And we can solve that like so. So if 128 centimeters cube is equal to b cube over 27. And we can solve that, and that will give us an answer of b is being equal to 36 centimeters. And that concludes this video. So hopefully you guys enjoyed this. Please subscribe for more videos, and I'll see you guys in the next one. Goodbye.